The middle ear is the portion of the ear medial to the eardrum, and distal to the oval window of the cochlea. The mammalian middle ear contains 3 ossicles, which transfer the vibrations of the eardrum into waves in the fluid and membranes of the inner ear. The hollow space of the middle ear is also known as the tympanic cavity and is surrounded by the tympanic part of the temporal bone. The auditory tube joins the tympanic cavity with the nasal cavity, allowing pressure to equalize between the middle ear and throat. The primary function of the middle ear is to efficiently transfer acoustic energy from compression waves and air to fluid membrane waves within the cochlea. The middle ear contains 3 tiny bones known as the ossicles, malleus, incus, and stapes. The ossicles were given their Latin names for their distinctive shapes. They are also referred to as the hammer, anvil, and stirrup, respectively. The ossicles directly couple sound energy from the eardrum to the oval window of the cochlea. While the stapes is present in all tetrapods, the malleus and incus evolved from lower and upper jaw bones present in reptiles. The ossicles are classically supposed to mechanically convert the vibrations of the eardrum into amplified pressure waves in the fluid of the cochlea, with a lever arm factor of 1.3. Since the effective vibratory area of the eardrum is about 14-fold larger than that of the oval window, the sound pressure is concentrated, leading to a pressure gain of at least 18.1. The eardrum is merged to the malleus, which connects to the incus, which in turn connects to the stapes. Vibrations of the stapes footplate introduce pressure waves in the inner ear. There is a steadily increasing body of evidence that shows that the lever-arm ratio is actually variable, depending on frequency. Between 0.1 and 1 kHz it is approximately 2, it then rises to around 5 at 2 kHz and then falls off steadily above this frequency. The measurement of this lever-arm ratio is also somewhat complicated by the fact that the ratio is generally given in relation to the tip of the malleus and the level of the middle of the stapes. The eardrum is actually attached to the malleus handle over about a half a centimeter distance. In addition, the eardrum itself moves in a very chaotic fashion at frequencies greater than 3 kHz. The linear attachment of the eardrum to the malleus actually smooths out this chaotic motion and allows the ear to respond linearly over a wider frequency range than a point attachment. The auditory ossicles can also reduce sound pressure, by uncoupling each other through particular muscles. The middle ear efficiency peaks at a frequency of around 1 kHz. The combined transfer function of the outer ear and middle ear gives humans a peak sensitivity to frequencies between 1 kHz and 3 kHz.